Today we're going to talk about sector area and arc length to begin with. How is proportional reasoning used to find the areas of circle sectors and lengths of arcs? Find the areas of sectors, find the arc length. We're going to talk about sector of a circle, segment of a circle, and arc length. On your mark, get set, go. The sector of a circle is a region bound by two radii of the circle and their intercepted arc. Okay? That's not necessarily as important as is that formula that you see. It's also at the bottom left-hand column of your formula sheets, right? You will see the formula on your formula sheets. It's written as area equals pi radius squared theta over 360. So, what's the formula for the area of an entire circle? Pi radius squared. You learned that 4th grade? 5th grade? What is it? You have really... No, I'm not even going to... I can't even troll you today. Alright? So, check it out. They only gave you half the formula. Okay? I'll explain that here in just a second. When we're talking about the area of a sector, let's think about this, guys. How many of you have ever had a pizza? Good. How do you eat a pizza? Does it come in? What? Slices, okay? So when you take the area of a circle, think about this. When you take the area of a circle, you're going to take the area of an entire pizza, right? Let's see here, Mr. Hobbs. You just said area of a circle and pizzas, because pizzas come in circles. Yes, that's right. Yes. Yeah. Pizzas come in circles. Yeah, I know. And that's not the type of pizza I'm talking about, okay? 95% of pizzas come in what? Thank you. Square boxes. Trying square boxes. Ovals.
They do.
All right.
Polygon.
That's true. You kids are in for a long weekend. I'm just here to tell you.
Some of them come in hearts too.
Aww.
Those down mama with a clutch. Yes, yeah.
She ain't never seen one of those.
Alright. If we took the area of a slice of that pizza, that would be the area of a sector. Okay? So what we're talking about is, instead of talking about the area of an entire pizza, we're just talking about the area of a slice of a pizza. Okay? Here's what I mean when I talk about the formula. You said that the area of a circle was pi times radius squared. Okay? And that's not wrong, right? It's just not the entire or full formula. That gives you the area of how much of the circle? How much of this circle did you find the area for?
200 area.
This is going to be an interesting day.
Yeah, I guess.
How much of the circle incorporates the area? All of it! All of the circle, right? And we're thinking about all of the circle.
Yeah.
How many degrees are in all of a circle?
All
360 total degrees, right?
Yes.
There are 360 total degrees, okay? When you're looking at a sector of a circle, you got to keep a couple things in mind. First up, we talked about radius, and when two radius meet, they form what's called a central angle. So that was yesterday, right? ACB is a central angle. It's at the center of the circle. We said central angles are congruent to these arc measurements out here, right? When I calculate the area of a sector, I use the formula for the area of a circle, but I plug in a fraction that incorporates the arc measurement over 360. So if I wanted all this, I would take pi times pi times radius squared, let's give this a value. Let's say it's 100 degrees, okay? Let's say this is 100 degrees, okay? I'd take pi times radius squared times 100 over 360, all right? That's going to give me the area of all of this shaded in red, okay? Got me? Everybody with me on that? Like a piece of the pizza, right? Let me fulfill your understanding. If I wanted to calculate the area of the entire circle, how many degrees am I going to be looking at? All 360. How many total degrees are in a circle? 360, right? What does that fraction simplify to? Right? It cancels itself out. So they didn't give you the entire formula back in middle school, all right? Elementary school, whenever it was. You'll see what I'm saying here? They just gave you, they left out the missing part that we now have here in 10th grade, okay? You got me? So that's where you got to make sure you're paying attention here. Am I calculating for the entire circle, or am I just calculating for part, or a piece, or a sector, or section of that circle? Okay? Y'all with me? All right? It seems pretty easy because it is, all right? All right, here we go. Set this up for me. What's the radius here, Brady? $12 meters. Say it with confidence. What's the central angle? If the central angle is 131, how much is the measurement of arc JH? Nope. 131. Okay? Because central angle measurements are congruent to arcs that create them. Okay? So that arc measurement's the same. So Brady, if I wanted to put this into my area of a sector formula, I would do pi times radius squared times what? 131 over 360. You guys calculate that for me real quick. Calculate pi times radius squared times 131 over 360. 50.1? Point suicide, no. Okay. 164. What I thought it was too. Okay. 164.5, somewhere in there, right? Holly? Is that what you got? Good deal. All right. I think y'all can do that one on your own. Check this out. Then you get a word problem like this. What's the key to word problems again?
Picture.
Draw a picture. Mr. Scarborough, it says that a wiper blade is 18 inches long. How long is the wiper blade?
18 inches.
So I probably need to draw something that's about 18 inches, right? Okay. All right. What unit are we working on here, Tyler?
Inches.
Nope. No, I don't mean unit of measurement. What's our big theme for today? This whole unit's been about what? What kind of shape?
Circles. Oh yeah, circles.
Circles, right? So let's go ahead and assume that we're going to deal with a circle that has a radius of 18 inches, right? Here's why we're going to assume that. We keep reading and we say, to the nearest square inch, what is the area covered by the blade as it rotates through an angle of 122 degrees? Does this make sense now? Okay, ooh, that's bad. Don't worry about my drawing, okay? If this was my blade, you know, you've seen a car before. I know Maddie doesn't have a car. She probably not seen one, right? But like, cars have what's called, cars have what's called windshield wiper blades on them. Yeah, even mine, all right? Actually, mine has 3 because it's really cool, okay? And it goes back and forth, all right? Just like this. Got me? Even the one in the back windshield. It's about, you know, it's about the size of the desk, okay? So if I wanted to calculate the area of coverage of this blade, it would be pi times 18 squared times 122 over 360. Everybody on board with that? Cool. Johnston, what's a segment of a circle?
Region bounded by an arc and chord.
Perfect. A region bound by an arc and its chord, okay? You don't have to write that down. You do have to write this down. The area of a segment equals the area of a sector minus the area of a triangle. Won't lie, I think this is the trickiest part all day. So, why do I say that this is a little difficult? Here's why I say that, okay? All right, what you have to do is, to find the area of a segment, you take the area of a sector, which we just did, which was really easy, pi radius squared times theta over 360. And you subtract out the area of the triangle. And it's that area of the triangle that sometimes trips people up, okay? Check out this one. It says find the area of the segment L and M to the nearest hundredth. So here's what it's asking for. It wants you to find the area of this shaded part, okay? Here's how we do it. We first find the area of all the stuff in red. All the stuff in red is your sector, okay? Mr. Kennedy. How do we find the area of a sector? Why don't you look at your notes?
The area of a segment and the area of a triangle.
How do you find the area of a sector?
Area of a segment in the area.
How do you find the area of a sector? Help them out.
Pi r squared and then whatever the sector, or not the sector, the arc degree is over 360.
Pi radius squared times the measurement of the arc over 360. In this case, it's pi times 9 squared times 120 over 360. Okay? Mr. Kennedy. Here's the problem with this. That gives me too much, right? Remember that original part that was in gray? Y'all saw that original part in gray? If I want to take out the triangle that is over included, okay? Do what? Simplify it? Yeah. So I've got the big area, which is 27 pi, and I'm going to take out, and when I say take out, that means like subtract the area of the triangle. Finding the area of the triangle is a little more difficult than you might think, though. Okay? All right. When I say the triangle, I'm talking about this triangle. L, N, M. Ms. Swan, if this is 120 degrees, what is that measurement right there? 120. So N is 120 degrees. Everybody agree on that? Okay? How many degrees are in every triangle? 180. Okay, 180 degrees in every triangle. We've subtracted out 120 right there, correct? How many's left over? 60. Now, I told you I'd say it every day. I'm about to say it again. All radii are created equal. So if MN is 9, how much is NL? 9. Which makes this what kind of triangle? Two congruent sides. What? Isosceles triangles. And in isosceles triangles, the angles opposite the congruent sides are congruent. So I say all that, Mr. Vo. I have two angles that have to be congruent, that have to be equal to 60 when I add them together.
30 and 30.
Perfect. Divide this by 2, I get 30 degrees. Okay? That doesn't solve the problem for me, but it makes life a whole lot easier. when I look at this triangle, I've got to find the altitude to get the height. I've already figured out that those angles are 30. Okay? Let's think about this. Remember, LN and NM are both 9. This is 9 and this is 9. Guys, how can I figure out, this is a hypotenuse, how can I figure out what this side right here would be? That altitude side? Perfect. Come back. Just stole my thunder, man. What were you going to say? Son? Good. Okay. I can use the sine of 30. The sine of 30 equals opposite over hypotenuse, right? Cross multiply with some trig right there. Tell me, what is 9 times sine 30? Vote. 9 times sine 30.
-1.
No. 9 times sine 30, close the parentheses. 4.5, okay? So this is 4.5. This is 4.5. Now, check it out, guys. I've also got to find the entire base, okay? Find the entire base. Let's go back to this angle. This is cut in half, right? I've got an adjacent side. I've got a hypotenuse. I use cosine of 30 equals, cosine of 30 equals adjacent over 9. Cross multiply it. What do I get? Cosine 30 times 9, or 9 times cosine 30, we got 7.79.
Yeah, that's what I got.
Correct? Okay, now think about this. Half of it's 7.79. What's on the other half?
17.9.
What is the entire length of the base?
No, never mind.
15.56.
15.56. Okay? Woo! So we've got now area equals 1/2 15.56 times 4.5. Let's see how close we get to this number. Okay? In your calculators, go 1/2, or you can go 15.56 times 4.5 divided by 2.
So that'd be 15.58.
Yeah, it's 58, not 56.
Okay, change it to an 8. What'd you get, Paige?
1/2 times 15.56 equals 35.055.
Right there?
Yes.
Okay. Somebody type in 20.25 times the square root of 3. See how close you get to this. Why aren't you doing it?
That is 35.07.
It's pretty close, right? Okay. What you would do, guys, is you would take 27 pi. Remember this answer, right? 27 times pi. You could convert that to a decimal if you wanted to. Subtract out 35.05. Get your answer. Okay. Again, it's a really complicated problem, right? You got to start off. Yeah. I mean, this is the hardest problem I'll give you today. Okay. You got to start off finding your area of the sector. That's easy. Then finding the area of the triangle can be more difficult. Okay. Trust your trig, right? Trust your trig. It's simple. It's only 2 trig problems in a row. All right. But just know that's the thing. Okay. Alright. We gotta get through this last part, and then I'm gonna give you a quick break, and then we'll go to the second half of the lesson. Okay? Alright. In the same way that the area of a sector is a fraction of the area of the circle, the length of an arc is a fraction of the circumference of a circle. So if we talk about arc length, we're talking about the distance along an arc measured in linear units. Let's go back here. Sutton, did you do your homework last night? No. Well, never mind. Not you, Sutton. Brady, did you do your homework last night? Brady, did you come across circumference? Circumference. Because it was on the homework.
Yeah.
Yeah, it was easy. What's the formula for the circumference of a circle?
Oh, pi r squared.
No. Circumference of a circle. Left-hand column.
E equals pi d over c equals 2 pi r.
Okay. The circumference of a circle is equal to pi times diameter or 2 times pi times radius. Why would it be okay to say 2 times pi times radius?
Because
2 radius.
yeah,
What's the relationship between diameter and radius, guys? Radius is half the diameter. Diameter is twice the radius, correct? Y'all see that? Now let's use our intuition here. If this gives me the circumference of the whole circle, how many degrees does it incorporate? Out of how many? So it's the same formula, right? You'll see that? It's the same thing we just did. We don't teach you in middle school that you have to have those 360. And honestly, here in high school, you don't have to do it, okay? Because it's always going to simplify to 1. But it's a teaching principle, okay? When we're talking about an arc length, I'm no longer talking about all 360 of those degrees, right? I'm talking about a portion or a part of the 360. You got me? That's why there's a fraction at the end of the formula. Everybody with me on that? You got that? Okay. So, calculate this one. Okay, I want you guys to calculate this arc length. Ms. Miller, either. What's the diameter of this particular circle? Well, 16. What does 8 represent? The what? Good. So this is the thing you got to look out for on these props, okay? If the radius is 8, that means that the diameter is 16. So if I put this into my arc length formula, you're going to get this. Length equals pi times 16 times height.
Would it be after that, you times it by 134 over 360?
Perfect. 134 over 360.
And then you'll get 18.7.
That's all you got to do. So,
could you do the same thing, but just put 8 squared? I mean 8.
No.
I didn't want that.
it's not, yeah, it's the area. That's it right there, guys. Pi times 16 times 134 over 360. That'll give you the arc length. Okay? If it's 8 squared, that's the area. So you got to know the difference between length and area. Right? Length and area. Big deal. Okay. We are at the end of